It seems I'm honored to be sitting in front of this camera in this moment called now. If we go back 30-some years with Hannah Kroger at her little place in Boulder, I still remember her restaurant on Pearl Street, where she fed me and everybody else with great love, intuitiveness, and an intention for a new paradigm for health on the planet as individual, collectively. That includes you that are watching this DVD. My specific paradigm is as a scientist, starting out very young as a dumb dyslexic, that I tried to graduate the lowest in high school in order to have a distinction, and somebody beat me out from the bottom. And eventually I began becoming a scientist, where I spoke international, the World Bank, Geneva, the Keenan Institute for Advanced Economics. And basically what you find is a collective of people that were all in Hannah's restaurant. There is no difference, there is no bad guy, there is no over there, there's only you and I, and somebody just showed me something to tell you what my name is, which is Jim Starry. And been published 51 times in world media. What this DVD is to demonstrate is 5, 6 different simple technologies in which us as collective humanity can show that we can change global climate change into a condition, knowing first that we created it, and second, that we can reverse it, take control of it, and give humanity a new paradigm to participate with as knowing cause. We kind of created this all without knowing. Now the moment of now is to know that we created that without judgment, and then look at a few simple solutions today to see how easily it would be to create what we really want. First that comes is I used to be a scientist, still am, but I pretend to be dumb as a rock. It's a great vernacular to know that God created the rock, and it brings you infinite humility to know that that stability is there for all of us. But as a scientist, floating small Mylar scrim balloons around the world 13.5 times, we called it the ghost system. And the Russian scientists had a big party vodka at the National Center for Atmospheric Research in Boulder, where the State Department found that we were overflying the Russian airspace, in which case they took all our funding. But we still got the job done. We found by interrogating these small balloons from satellites, buoys in the ocean, that we could tell perfect weather around the world. That the unity of our conditions of burning 7 billion tons of coal a day, collectively 85 million barrels of oil a day, as we as individual collectively have changed the current condition of Mother Earth. So seeing that in the 70s and sometimes earlier, I have designed 5 technologies which, if we join together and use them, speak them, they belong to everybody, because they're just God's essence into physics as a function of purifying the water, the air, and the land again. So if we can go to this drawing over here, which is basically the simplest one, we can see in Boulder, Colorado, if we just happen to take a moment and be in Boulder Canyon, Boulder, Colorado, there's a Barker Reservoir here, which is a large retainment of water. And the reason I'm starting by speaking on water, it's the attention of everybody on the planet currently, that if you take between Barker Reservoir and Boulder, there's a 2,000-foot elevation fall. If you look over here at the retention ponds, and at this device here, which is made out of natural stone, I always tell the joke, what gets bigger when you take away from it, it's a hole in the ground. So if you look at this area here piled up at this point, and then a small impoundment dam, much as the beavers would create, which they actually did purify water, reoxygenate it before man became predominant. We basically are recreating a system of 300 or 400 small little impoundments on this 2,000-foot fall coming into Boulder. Now the reason for that is, if you take a look at the bottom section here, there's a small dip in the opening. So normally the water flows down and flows out of this opening, aerates, and creates an impoundment behind this of approximately 3 feet from this point to this point. What that does then is make trout habitat and a pool of water at 300 or 400 locations between Nederland and Boulder. By doing that, the trout habitat is increased, and we now look at the condition of environmental rapid change creating floods around the world. So if there was a major flow increase, it comes from these small little cracks in the canyon flowing into the main body. Most time it takes place when the land freezes, sometime between a warm period and rain. Then the ground freezes and has no percolation, so the water then becomes free-flowing over the land into the ravine and is trapped behind these impoundments. So if you have 300 to 500 of these different impoundments, what you do then, the water won't flow out of this opening rapidly enough, and it's held up at this high level, which is the flood level. So you've taken out an acre-foot at 300 to 500 different locations coming all the way down, which means that the flood is not allowed to create itself. If you look at this gently, that all floods are created by numerous little inflows into the main stream for a short duration. Now, taking that and collecting it behind these impoundments, you keep the flood from reaching Boulder in this case, or in China, or in any country. Simultaneously with that, there's a tube which goes down the side between these impoundments to the next impoundment, which is used for power generation. Simultaneously, the power generation is, before you get to the municipal area, it's water purification and power generation. Then after the water leaves the municipal area having been used, you re-purify it before it goes to the next town. Now if you look at the Mississippi River, there's 500 towns on an aquifer used over and over, where people dump their sewage back in the river without purification. But in the fall, when you have this point to this point, for every foot of fall you have a PSI increase in pressure. So finally we got it from Barker down about halfway. We put in a power generation station. Somebody figured out they had 1,000 PSI, which was way too much for any of the water pipes, so they generated electricity for free. And in doing that, the generation was a byproduct of the water's flow. And so if you look at this condition of taking any municipality anywhere in the world, Amsterdam now is a $910 million dike system, which is about to do a Katrina experience. So if we were to design all the aquifer flows in the United States and the world over time through this dimension, we've eliminated floods, we've generated power, we've purified the water before it goes into municipality, and purified it after the municipality using what we take out of the water as a genetic infusement to land through control that makes the soil more fertile, because 90% in the world, if you take any flow over distance, especially in Africa and other countries, Nile, it carries the land mass away into the ocean, and this way we can recollect it, report it. So let me see, let's cover this. So we see that we have water purification, we have flood control. So how would this be a firefighting system? Well, as you look at this point, this is one as a possibility. With the flow, when it's behind in a flood stage, we can redirect this water off into an impoundment. As the Black Tatter Gulch fire, there was a lot of use of the water in the creek for firefighting. It was probably one of the main things that contained the fire. By making these impoundments at different locations in the mountains, such as we look at a large impoundment here, the choppers can drop in, pick up 600 gallons, fly to a fire in less than 12 minutes in the county, put the fire out before it creates its own wind and wipes out 252 homes and burns across the radioactive dump site where the media called it a controlled burn. The point is we can actually control a fire not to last any more than 12 minutes in the county and 6 minutes in the city by creating water at easy access. So we're basically creating a flood control firefighting system that can be used around the world. Okay, we're going to take a slightly different flight of fancy and paradigm. We're going to look at the world condition of a secret not told, except for this moment of now it's being told to you. And what it is that Al Gore, House Bill 2107, that sounds pretty complex, but it's not, Federico Pena and Mr. Clinton, in order to make jobs in the United States and around the world, other people do copy us, $53 billion were given to expand airports. Most everybody everywhere remembers Denver International. We took 52 square miles of wheatland. Think of that, 52 square miles of something that would feed us and turned it into concrete runways. The design which I was demonstrating to the FAA, the EPA, the mayor, the governor, the media, and most importantly you, because you as an individual are the choice maker of this new paradigm. 2,000 U.S. airports were going to be expanded in the manner that you see in front of you. What you see over here on your left is a plane landing at high speed, approximately 130 knots. So most of you have been on a flight, and you touch down way, way down, and deaccelerate brings something close to 1,000 gallons of fuel. Once you've slowed down, you then make a turn to the right and begin making a taxi sometimes over 2 miles. Think of that, 1,000 flights a day, taxiing 2 miles, all this distance over to the terminal. Once you're at the gate, you've burned from this point 500 gallons of fuel to get you to the gate. After actually wasting 1,000 gallons of fuel to slow the plane down. Hence you go up and you see cost implies a time, distance, fuel waste per day equation per passenger. So if you come over here just for fun, we'll throw in what they call the penalty box. That means at 8 o'clock, 9 o'clock in the morning, your flight has left this gate, taxied over to the runway, but is waiting up to 20 to 48 planes with their engines running, creating pollution, noise, in order before they take off on this runway. So let's just look a little more accurately. Time waste passengers, 15 minutes times 200 passengers, 1,000 flights a day, is 5,000, 50,000 hours. $10 an hour is only $500,000. But you go in to the terminal and back out, that time waste is $1 million per day for the passengers. The airline time waste is $200 per hour for the staff, $500 maintenance. Aircraft depreciation is about $700 an hour, 1,000 flights. There's another $700,000. Okay, we then look at the passenger time waste from getting from your home to the parking, from the parking to the terminal, and then to your gate. A mile times 200 passengers per 1,000 flights, 100,000 hours at $10 per hour. I think most of us are worth more than that. There's another $1 million. So then when you come down here and count up the fuel waste, the taxi, the penalty box, the 500 gallons to taxi you from the runway to the terminal, 1,000 flights per day, 500,000 gallons of fuel. It's almost $3 a gallon now, but it's another $1 million. Then you look down here, National Center for Atmospheric Research states, this is Dr. John Fire, Director of Advanced Studies for NCAR, 1 gallon of fuel creates 10,000 gallons of air pollution at 1,400 degrees, and the cost per day in respiratory diseases, cancer, fibromyalgia, acceleration of global warming is a huge question mark. So what we're going to do now is turn this problem to a solution called Starport, which eliminates all of this time, distance, fuel waste, and pollution by being built on 1/3 the land at half the cost while creating 4 times the commercial income, saving 3.7 million a day per 1,000 flights. O'Hare currently is going to 5,000 flights a day. So that would be 15 plus million gallons of fuel per day. Okay, now we'll just flip it over. You ready?
Yep.
Okay, so we're going to take a moment now and be on approach.
I don't think we can see it. We can see it easier on your camera than on this. See how it's not very dark? You could get closer, and I think, oh, on the camera it's beautiful.
On a flight back from England sometime in the early 80s, Spirit came through, and I asked the airline stewardess in a very anxious voice to get me a piece of paper and a pencil because something was coming through. So I started drawing an arch like this repeatedly, over and over. And after 5 years, I finally came up with what you're looking at, because what happens here is a plane lands, goes uphill to deaccelerate, saving 1,000 gallons of fuel, and crests the top of a highway overpass and pulls that out to the gate, eliminating taxi and deacceleration by going uphill gently. The beauty of that is, as you look again, as this plane lands, a large plane lands back here and deaccelerates through this distance. A smaller plane would land maybe in the middle and use this distance to pull out to its gate. Now, ultimately, this runway over here is for small commuter aircraft because, as you see, the wind could blow across, and these are protected. So a plane can land here, taxi to the terminal, transport passengers, and elevator up to this plane, which then, oops, it takes off downhill. So it saved 1,000 gallons of thrust reversal, 500 gallons of taxi fuel by doing what a child would do on a skateboard, by going uphill, ending up at the terminal. Now you, obviously, will drive in under this terminal to your plane, or this terminal to your plane, and park directly below your gate, hopping onto an elevator straight above to your aircraft, which then, very shortly, no taxi, takes off on an equal and opposite ground grade, and away you go. When you look at this runway system, you see that there's a commuter runway here. Say this terminal is United. It has a runway for landing, a runway for takeoff, a runway for landing, a runway for takeoff. So what you've done is you've saved 1,000 gallons of thrust reversal, 500 gallons of taxi fuel, that's 1,500 gallons, picked up your passenger, saved another 500 gallons because it's much easier to take off downgrade. So you've saved 2,000 gallons of fuel per flight 1,000 times a day, which is only 2 million gallons of fuel. We'll not multiply that by 10,000 to get the gallons of air pollution. What that does is eliminate noise, fuel waste, pollution. If you were to look up areco.org and look up EPA cancer study for your airport that you live within 50 miles of, cancer is 400 times higher. By eliminating this taxi, deacceleration, fuel waste, cancer would be cut by 30 to 50% in your city. When you look at this design as your design for your community, Al Gore is expanding 2,000 U.S. airports, 10 on the California coast, Oakland, San Francisco, San Carlos, San Pedro, LAX, San Diego, and San Jose. This is an epidemic of expanding airports to make jobs. Mr. Obama just added $50 billion. So that's $103 billion to expand airports. If we do the starport design, we save 22.2 billion gallons of fuel per day. We bring our children home from Iraq, obviously. They're not over there for oil. They're there for sand sandwiches, part of the humor. But we lead the world in green technology. We eliminate cancer, diminish it greatly, fibromyalgia, Alzheimer's, etc., in the United States, and lead the world in green technology. China, 405 airports. India, 28. Europe, 3,000 expansions. I speak at Dubai, New Zealand, Auckland has 16 different airports. This solution spoken by you as your own. All of you know someone in politics. They're not the other. They're us. They're our friend, our brother, our sister. Our gentle communication to these people in media and administration. Email this to Mr. Obama. Michelle is waiting. We can change the world. You and I together are the difference in this moment of now. Thank you for your listening. Oh.